more like a math, quote-unquote, adjacent thing, kind of like our math word search, or just our random numbers, readings, or our digits of E, digits of pi, recitations, that kind of thing. So thought this would be a nice, relaxing little series to bring into our math space as well. And I love this game. I've played it since I was in, must be like middle school. Now, my original set of cards were purple, and I've gone through a couple of sets of set decks. Easy to like lose these cards because there are so many. It's not a standard 52 card deck. We'll get into that. So anyways, feel free to let me know in the comments whether you've heard of this game before. And it's okay if you haven't played in a while, or if you've never heard of it. We're going to go through all the rules today and kind of let it sink in a bit, because I think it's a little complicated initially, but I hope that you come to love it as much as I do. So we can play around with these cards in the future. I definitely plan to, and maybe even play some rounds like in a stream or something if anyone's interested. But we can just definitely play around with these ideas anyway, regardless. So what is fun about this game is, like I said, because it is more like the actual gameplay is more perception based. What you end up doing is you flip over 12 cards and you're looking for sets. So you can play this with however many people you want, and you can go at whatever pace you want as well. So if other people are up for a challenge or for a little race, you can race to find the most number of sets. But you can also just take your time and play on your own and kind of see if you can find sets. And it can be really relaxing and really satisfying when you actually do find one. So, and I think it makes for nice ASMR, I imagine, so when you actually find one in this relaxing way. So we shall see, put that to the test. But today let's go over the actual setup, the cards, and what makes up an actual set here in this game. So, like I said, this is not a standard 52 deck of cards. There are way more, and we'll actually calculate how many cards there are. But let me just, pull out some random ones here, like so you can get a feel for what they look like. Okay, there's lots of stuff going on here, and okay, so you get the idea. We have a bunch of shapes going on. So the first thing to note is we're not actually playing this, so I'm gonna just overlap some of these, but normally you'd put this, across an entire table. So the first thing to note is you lay out the 12 cards, and a set is a group of 3 cards. So that's the first thing. An allowable set in this game is 3 cards. Okay, but not just any 3 cards. We need actual rules for what is allowed to be a set. So before we get into defining a set, let's look at each of these cards a little closer. So each of these cards are unique. Okay, so there's only one card that looks exactly like this in this deck. Okay, and so we can actually categorize each of these cards using 4 different attributes or different characteristics. And within each of those characteristics, there are 3 possibilities. So, in no particular order here, would be 3. This one would be 2. And so there are 3 options. It's either going to be 1, 2, or 3. So there's not going to be a blank card. There won't be 4 or 5. It's literally always going to be 1, 2, or 3. So 3, 2, 3, 2, 3, and 2. Okay, and 3, and 1. Okay, so it's going to be 1, 2, or 3. And I say no particular order because not everyone, thinks of the same attributes. So, certain things might stand out to you about each of these, like in a different way than, the next person. So, number is just one of them. The next one we'll go over is, how about color? So, for color, we'll always have either red, green, or purple. So, red, green, and purple. And unfortunately, I am kind of sad about this for colorblind people because I think red and green are the most common colors that can't be differentiated for colorblindness. Correct me if I'm wrong, but I do have a heart out for people who can't differentiate this because that will make this game impossible to play. But we do have red, green, and purple right here. And so there will be no other colors, no blue, pink, black, white, whatever else. It's always going to be red, green, and purple. So purple, green, purple, purple, red, purple, purple, red. Okay. Then the next attribute is shape. So the actual shape of these, the shapes of the shapes. So we have diamond, and they're always going to be sideways like this. So diamonds all look like that. So we have diamond. So diamond. We have like this oval. It's not exactly an ellipse, but okay, whatever. We don't need a whole math lesson here, but it's kind of like this rounded thing, so I'll just call it oval. But it's kind of straight and then whoop whoop. So it's kind of like this rounded oval thing. We'll call it oval, whatever. It's moments like these where I realize how big of a nerd I am. And then we have squiggles. So squiggles. So, or a squiggle. And so that's just going to be our whoop. Whoop. Okay. So, diamond, oval, squiggle. So, diamond, squiggle, oval, 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 diamond. Okay, get the idea? Squiggle. So it's going to be one of those 3. And then the last category or attribute will be the shading. And that will be either empty, so just not filled in, just blank, or we'll have striped like this. So striped. And they'll always be vertical like this, so So then we could have 2 red diamonds that are solid. And we'd have to dig to find that one exact card. Does that make sense? So then we could have 1 green diamond that is solid, or 1 green oval that is striped. And so we'd have every combination here. So on that note, how many cards then are there in total if we have every single combination here? Now that is our math question for the day. So we have 4 categories or attributes, and we have 3 possibilities in each. So the total number would be 3 for the numbers times 3 for the colors times 3 for the possible shapes times 3 for the possible shadings. So this is 3 to the power of 4, which is 9 times 9, which is 81. So there are, or should be, 81 cards in total. So that's how we get that, because you can kind of treat each one as a tree if you wanted to. Kind of think of it this way. So you could do 1, 2, 3, but then within the one tree, you could have red, green, or purple. And then within the one red part, you could have diamond, oval, squiggles. And then within each of those shapes, in the one red, whatever shape, you can have empty, striped, or solid. And so going down the path of that tree kind of implies a multiplication for how many extra choices you have as you kind of move down this tree. Or you can just kind of use this combination formula here to multiply the different choices you're making to find a total. Either way, we have 81, 4 attributes, 3 choices within each attribute, and so each card has a unique labeling. Okay, so that part is important in deciding what our allowable sets actually are. So here is the actual rule, okay, as if this isn't kind of confusing to note. So this alone is actually really relaxing now that I'm doing this whispered and a little bit slower paced, but this is this is all it takes, but there are so many variations and so many possibilities for this that it seems deceptively easy. So let's look at an example of what this means. So I'm taking sets of 3 cards, okay? So I lay out all my cards. Let's say I just grab 3 cards. Most likely they will not be an actual set, okay, or an allowable set. And sometimes if you call set and then you grab a thing that's not a set, you get -1 point. So let's say we grab these 3, okay? So this is not an allowable set because within the category of number, let's start with this, just go one at a time, but for number, we have 1, 1, and 2, right? So within the category of number, these are not all the same. They are not 1, 1, and 1, right? So they're not all the same between all 3 of them, but they're also not all different. So we don't have 1, 2, 3, for instance. We still have 2 of them that's the same, but not the third. So they are not all the same, nor all different in the category of number. So if it has to apply for each category, then that already fails that so this is not a set to begin with. But if we continue even to color, we have red, red, and purple. So within the color category also, these are not all the same. They're not all red, but they're also not all different from each other. So we don't have a green, purple, and red. We have 2 reds. For shape, we actually are okay here because we have a diamond, oval, and squiggle. So they are all different in the shape category. So that one category is fine, but this needs to apply for all the categories, each category together simultaneously. For the shading, we have 2 solids and an empty, so they are not all the same. They're not all solid, but they're also not all different. So we don't have like solid, striped, and empty. We have 2 solids here. So basically, you can't have 2 of one thing and then 1 of the other. It basically undoes this. So that's why this is not a set for many reasons here then. So it does not apply for the 3 categories. The only one that is acceptable over here would be shape. So if you note this, it turns out that you can use any 2 cards, and there is a unique card that fits the actual set. And this is where it's kind of the pattern recognition. It's very mathy. I think even before we actually play a full-on round of set together, if you want, we can actually do this relaxing exercise of simply, well, first of all, we can determine whether or not something is a set, but then we can also play the game of, if these are the 2 cards that are given, what would the third one have to be in order to make a set? And I think this is all really good practice to get better at the actual set game as well. Anyway, so for instance, let's go ahead and do this exercise. If we were to find the 3rd unique card that fits this set, what would it have to be then according to this rule? So in the category of number, they have to all be the same or all different. So here we already have 1 and 1. So the 3rd one would also have to be 1 in order for them to all be the same. So we need 1, right? 1 of something. For the color, we have red, purple, so we need green, because if this one is red, then we have 2 of the red and 1 purple, so they're not all the same. one green something. In the shapes, we need a squiggle because we have diamond, oval. So this can't be an oval or else it would match this. Can't be a diamond or else it would match this, but then this would be different. So this has to be a squiggle. So one green squiggle. And then for shading, these are both solid. So this one has to be solid also, so that they are all the same. So one green squiggle solid. So let's go ahead and search for this, I suppose. And it's gonna be a lot to go through. Oh, there we go. Like this. So this would complete one type of set, and there are so many, as you can imagine now, because you can have the numbers all be different. You can have them all be like the same color, but the number is different, but the shapes are all the same, but the shading are all different. There's so many different types of sets. So this would be a set, for instance, but then so would this. I'm getting used to and playing around to actually kind of get used to the different types, but this would be a set because in the numbers we have 1, 2, 3. So those are all different. We don't have 1, 1, 2 or 1, 2, 2. We have 1, 2, 3. So that's good. In the color category, these are all red. So they're all the same in the color category. For shapes, we have all diamonds. So those are all the same. For shading, we have all different because we have solid, empty stripes. So this would be the kind where it's different numbers, same colors, same shapes, but different shading. So I know that when you play with more people, it's interesting because certain people gravitate towards certain types of sets. And so it kind of turns over the cards faster. But if you're playing on your own and kind of taking your time with it, you're just gonna have to train your mind to see different types than you might initially be drawn to. So, the most basic one would be red solid, squiggle 3, squiggle 2, squiggle 1, for instance, because that would be all solid, all red, all squiggles, all filled, or I said solid, but all filled, but different number. So just varying one at a time is an allowable set. That's probably the most straightforward one. And then depending on your own, preference for the category, you might find the ones that are all the same shape, all the same color, and all the same number, but have different shading, for instance. So one squiggle that's filled, one purple squiggle that's filled, one purple squiggle that's empty, and one purple squiggle that's striped, for instance. That might be your tendency. Now, the most, I think, complicated ones to notice are where everything is different. It's kind of like the opposite extreme here, but it's where everything is different in every category. So let's do this exercise. If we have everything is different in every category, these two could be part of a set. And so let's figure out what the third card would have to be. So if the numbers are all different, we have 1 and 3. So we would need 2. And we have, for the color category, we have purple and red. So we would need green. For shapes, we have diamond and squiggle. So we would need oval. And then for shading, we have striped and solid. So we need empty. So we would need a 2 green empty oval. Okay, so we gotta go find that now. 2 green empty oval. Guess we passed it already within all of these. Let's see here. 2 green empty that's why this would not work, because you have 2 diamonds, but the third is not the same, nor are they all different in the shape category. And same thing for here, they're not all different in the shape category because we have 2 squiggles and 1 diamond. So between all 3 of them, they're not all the same, nor are they all different. So if this were a purple striped squiggly one, then that would fit this set going this way. But this is not the card that fits between these 2. But kind of interestingly, these 3 though are a set. The 3 that I kind of put in there as fillers. So this one fit the all different in every category, but these 3 actually are a set because they're all 2. So all the same in the numbers, all green, so all the same in the colors, all empty, so all the same in the shading, but all different shapes, oval, diamond, squiggle. So that's allowed for a set. So we can play around with different types of sets like this just to get visuals. I'll do that in the future, but I hope that this kind of introduces the game a little bit and kind of piques your interest. And yeah, so you play out 12 cards, then you go ready, set, go, and then if you notice a set, you grab your 3 cards, confirm it, and then you have someone deal out 3 more to replace. And oftentimes so probabilistically there will be at least one set, sometimes many, sometimes overlapping sets, so that's why you kind of have to grab them as you see them. And very rarely is there absolutely no set within your set of or your group of 12 cards. It does happen, but it's very rare. As much as, staring at it for a while and just not seeing one, it just makes us want to be like, oh, there's no set here. But usually there is one. But if for whatever reason you can prove that there isn't, maybe there's only one, diamond purple thing, so you can prove that the other cards don't work with it or something like that, you can eliminate, then you just add another 3 cards and work from there, and then that's even more likely to find one, and you keep going from there. So that's the general gameplay here. Like I said, we can actually just do little fun relaxing exercises to begin with, like determining whether these are sets or not, and then we can also play the what's the third card that would make this a proper set?